So good morning. Quiz link is shared in the chat window. Those who joined late, I'm reposting that quiz link. Complete that one. So by that time, parallelly, I'll take the attendance also. Whether the class left late, second hour,
No, sir.
only no, right?
The quiz link is not working, sir. It's
What it is expecting? Response
not. It's
It's
like no longer accepting, sir.
accepting the response, sir.
accepting responses, right? Okay. 1 minute. Now check it.
Working, sir, now.
Okay. Okay. Finish the quiz. By the time we'll start this one. Answer your attendance.
Sir, quiz link is not working, sir.
It is working no.
No, sir.
No, second one. Second quiz.
Sir, if you don't mind, can you please post it again, sir?
Ah, okay. Posted now.
Thank you, sir.
Welcome. Aditya,
Yes, sir.
Ajay, Jay, Amit, Antima,
Present, sir.
Apurva. Apurva, you have submitted the PUID assignment rather than submitting to mobile application. Twice you submitted, uploaded the PUID assignment. Resubmit the assignment. Most of you are not submitted the assignment copies. Only few are submitted. Complete the assignment and upload in the either in GCR or in the Google Drive. Ashwini,
Yes, sir.
Bindu, Divesh, Gaurish,
Yes, sir.
Gautami, Gunashekar,
Present, sir.
Harini,
Present, sir.
Surya Prakash,
Present, sir.
Nayana,
Present, sir.
Nazma,
Present, sir.
Nidhi, Pradeep, Preeti,
Present, sir.
Rajesh,
Present, sir.
Sahadev, Sahadev, Saket, Santosh,
Present, sir.
Seema,
Yes, sir.
Sinchana,
Present, sir.
Spurti, Shashank,
Present, sir.
Upsha,
Present, sir.
Yashashwini,
Present, sir.
Amruta, Anusha,
Present, sir.
Apurva,
Present, sir.
Sai Siddharth, Chetana, Kavya, Madhushree, Manish,
Present, sir.
Sarfraz,
Present, sir.
Murgesh, Mani,
Present, sir.
Paresh, Pooja,
Present, sir.
Prashant, Pratibha,
Present, sir.
Pratik,
Present, sir.
Sadhana, Shashank, Shraddha,
Present, sir.
Sridhar,
Present, sir.
Tanuj, Tejashwini, Honey, Ashish, Vidyarani, Vishal,
Present, sir.
Sir,
Sir,
03.
present, sir.
okay. Uh, let's
Register
start
number
the
18.
class. Let them join, late joiners. At the
Sir,
end,
04, sir.
yeah, at the end, I'll consider the attendance. So
Oh,
now
sir.
we'll go start the discussion on the topics. Okay,
Okay, sir. No problem.
fine. Last class we have seen the uh, tools, SDK tools of iOS. iOS stands for iPhone operating system. Previously, it was told that Internet operating. No, it's the iPhone operating system. Okay, so there is a correction in that. Fine. Xcode and the iOS SDK. Xcode, as we have seen, is Xcode is the integrated development environment. It is similar to your Android Studio IDE. So it integrates all the packages which is relevant to SDK development. It is relevant to develop the iOS phone applications. Okay, so it is look like this one. The dashboard of Xcode look like this. You can just go with developer.apple.com. You will get all the necessary tools and SDKs. Depends on the application type which you are going to target it for the community of users. Okay, so the now in the current discussion we are going to look into the anatomy of the iOS. Anatomy of the iOS. This is the dashboard of Xcode. Different projects you can create. You can create the Mac, iPhone, or iPad application. You can integrate your source of control features to existing projects using connect to a repository. So and there is an help option and one more option available to connect to the internet for the developer use. So this is the dashboard running board which what you are seeing on in the PPT. Okay. So components of the iPhone SDK, already we have seen this one in the previous class itself. Just I'll go through once. Xcode, it uses the IDE for creating Objective-C applications. In addition to the Objective-C, nowadays Swift programming language is used for the same, and Dashcode is another IDE to develop the web-based iPhone or iPad applications. Then iPhone simulator to simulate the developed code, how it behaves in real time phone or the feature. You can test it using the iPhone simulator. So relevant to the HIG human interface guideline, as a new developer, you have to strictly adhere to the principles and standards and the guidelines which is given in the human interface guideline. Suppose if you have developed the iOS application and you are launching on the Apple App Store, first they will check with whether you are compliance with the HIG guidelines given by the Apple. So if you are passed through that, then only they are going to launch with some additional licenses and certificates. Otherwise, the very entry level criteria to deploy your app in the App Store is HIG compliance. Okay. So now let us look into the project structure of iOS. So with all of the setup out of the way, we can focus on getting into the IDE and looking at code. Since we are using the Windows laptops and Windows devices, we were unable to show you the IDE setup of Xcode. Rather than that, I'm going with the screenshots given in your textbook. Okay, suppose if you have the Mac book or the Apple no notebooks, if you would like, if you want to work with the iOS application, so you can download the Xcode and relevant APKs SDKs from the developer.apple.com. If anybody have the Apple notebook, anybody have from the group of 32 students, whether you have the Apple notebook or Apple phones. I think one or two you have the Apple phone. What about the Apple notebook? If you have, that is easy for us. I may ask you to share the screen, then we can go through the dashboard of Xcode in real time. Otherwise, just we'll go through the presentation clips only. Okay. Fine, no response from your end means there is no Apple device from your end also. Fine. So anatomy of an iOS app. So iOS app files are actually deployed to the iOS device are just a set of directories similar to your Android only. So Android project folder, so then libraries, then a resource folder, then source folder, then manifest folder. How it is structured in the directory structure. Similarly, the iOS app also, which will have a directory structure. Although there is an actual binary for the iOS application, you can open the .app file and find the images, metadata, and any other resources that are included. So same you can compare analogy of Android Studio folder and the iOS. Both are structured based only. See here the .app file here. .app represents a extension of a file, the source code which it is going to keep. dot app means dot apple file, and the images are which will be present under the drawable folder in Android Studio. In the same way here, images folder consists of the images, and metadata, so here it is called as metadata, there it's called as a manifest file. So, and any other resources like resource res folder which was there with the Android Studio, here it is resources. So the most of the project structure is similar, but little change in the naming convention. Okay, there we called them as activities, here we are calling it as a views. So GUIs are called as in Android is activity, here it is called as a views. There also we have a views and view groups, different view sets and basic views as well as the advanced view like widgets and all. Here also there is a views, views are there, it representation of GUI in Apple phones. So iPhone apps are made up of one or more views. Views usually have GUI elements such as text fields, labels, buttons, and so on. So these are the basic views exist with Android Studio also. The same views also here is a part of the iPhone apps. You can build a view built using the interface builder tool. See, as we are aware of that HIG, human interface guidelines, so there are a predefined set of around 3000 plus GIF images which can be defaultly used by the Apple phones. You need not to worry about to search that one. There is a template of plenty of images are available with the builder tool. Just you can use the drag and drop option to place the controls onto a views. So means there is a drag and drop controls to the view. Similarly, in the design mode and split window mode, how we did the drag and drop of the controls in Android Studio, in the same way also here drag and drop option is supported by Xcode IDE also. So code that makes the views work, because there we use .java and the Kotlin programming languages to work with the code along with GUI and manifest. Here also the code which is behind the scene of GUI, that is Objective-C or the Swift, and in addition to that C#, also we are going to use to deploy the iOS applications. If the iOS supports for the Microsoft devices, it is the requirement of make use of C# also. Because iOS applications follow the MEC design pattern as the .NET also. .NET, C# .NET also supports the MEC design pattern. It is a clean break between the UI and code that provides the application code. Model view controller architecture is also maintained by the iOS applications. It means that so one team specific to dedicated to the development of model, another team working on the GUI part like views, another team working on the server controller part. So a model view controller design pattern which will be used to maintain the clean and safer code of execution of the iOS applications. So the another folder is a resources folder. Usually the resources are the external resources like file or images or some binary executable files, etc. and so on, like multimedia files such as images, sounds, video. All these are called as resources. So those resources file usually it will consist in the file called as info.plist file. Info.plist file. The name of the resources extension is info.plist. it holds the information about the application itself and the binary executable. So R class file is there in Android Studio to maintain all the resources used by your Android application. In the same way here, the info.plist file is holding all the information about the application, about executable file, which are the resources, images, sounds, video, all those classified as the resources is maintaining in that info.plist file. So let us look into the little in depth of the project structure. Suppose if you are interested, suppose if you have a Apple device, better notebook, Apple notebook, then you can experience yourself online in real time. Project structure in depth. I think this is visible. Image is visible. If not, I will zoom it. Is it image is visible clearly?
Yes, sir.
Yes. Probably now it is better, right? See, when an iOS project is created within an Xcode, the IDE creates a set of files that are ready to run. Same way, you can compare yourself with Android Studio. So when you are creating the thing, so the first thing is observe here one target. The SDK version which it is used in this screen is SDK 5.0. Suppose delete me is a one project folder. Observe here, different applications are files are maintained here. See .h helper file, .m it's a main mobile file, main storyboard it is a GUI related .xml file similar to that. View controller, all the controls are mentioned in this .h. View controller which is a supporting file of it is a .m is a GUI. This is the header helper file is a code logical file. Supporting files like delete in me info.list plist, as we seen info.plist maintains all the resources used in the application. Info plist strings like strings.xml was present in the Android Studio. Here info plist.string related content is present in this. Main.m is the execution point of starting point of execution of your app application, that is main.m. Delete mean prefix, it's a supporting file of this supporting files. Then some of the frameworks use is utility kit framework, foundation framework, and core graphics framework. These are the built-in frameworks for any basic app application. Remember, frameworks will be used in the both Android as well as here in iOS phones also. Which are the frameworks? It uses utility kit framework, foundation framework, and core graphics. Then products build nature is the once if you build the product, the name of the project is delete me.app. So it is an executable binary file. It is going to be launched. The entry point is main.m. Okay. As with any C program, the execution of Objective C application start from the main function, which is the main.m file. Execution begin from main.m file. Next. So app delegate.m, it's an extension of the previous discussion, which is given in the diagram figure. App delegate.m it receives, app delegate receives messages from the application object during the lifetime of your application. So what it is receiving? It is a receiving the messages from the application object. There is a two context, application object and external context is other source of applications. Here their intent we were used, right, to receive the messages between the different activities. Here app delegate is used. Delegate is nothing but a extension of the service within the organization or within the application. The app delegate is called from the operating system and contains events such as the did finish launching with options. So did finish launching with options, which is an event that IOC would be interested in knowing about. So the app delegate is called from OS. It's a system level service to send messages between the activities. Here activities are called as storyboards. Here activities are called as storyboards. So main storyboard. So here in iOS it's called as storyboard. There we called it as activity. This is where the user interface is created. The extension of storyboard is .xlb. So it is like a main activity. Main storyboard is the very first activity of Android. Here it is called as storyboard. Extension is .xlb. Storyboards are a great improvement over .xlb files, XIB files for applications with complex navigation and many views. It is a main view of your application. Now, supporting files. The supporting files directory contains files such as plist setting files, which contain customizable application settings as well as string resource files that are used within your application. Just recall the Android structure, project structure, you can clearly understand this. There strings.xml is used to store the application related strings. Values.xml is used to store the values of the application string, values of the strings. Yeah, similarly here plist consists of all the customized related settings can be made in this supporting files. Clear? Now gradually we are moving towards the focusing our interest on storyboards. Storyboards is nothing but a view of an iOS applications. In iOS versions prior to the iOS 5, developers needed to create a separate XIB file for each view of their application. See, observe, before the existence of iOS 5, each activity has to be created separately. Then you are going to link using the app delegate .m file. So you are mentioning the link between the two activities there. So now in a XIB capital format, XIB file is an XML representation of your controls and instance variables that get compiled into the application. So here small XIB representation is earlier versions, capital case representation is an XML representation of the storyboards. What it consists? It consists of the components related to the views. Okay, so managing an application that contains more than a few views could get cumbersome. So this is always true statement in a mobile application environment. Since the mobile device size, hardware size is limited, keeping every view components of the same application in a single view, obviously it is cumbersome. So for that, you are going with the multi view activities, multi view storyboards, rather than going with a single view storyboard, right? So iOS 5 contained a new feature called storyboards. Story, as it is telling that story. Suppose login page, what the story it is telling? It is telling the story of user has to sign in before the user has to enter the credentials before entering to the application. That is a story of login, story of home page, story, right? Storyboards that enables developers to lay out their workflow using design tools built in within the Xcode. Xcode is an IDE. It supports even design of storyboards also. With the help of that, you are going to create a design view, and also you are creating the flow of the structure of the application. Suppose once if you log in, where it should go, whether it should go directly to the user page of main content or the home page of the partial content. So that flow diagram decides, by looking into the flow diagram, the user will come to know the working nature of the flow of the application. So that kind of things, usually what we did is we manually drawn the flow diagrams in the Android Studio. But whereas here in iOS, Xcode itself supports the workflow design tool. So yeah, you are going to create a storyboard and establishing a flow connections. From that, developer and as well as user is able to understand very clearly about how the application data flow between from initiate state to the till completion state, right? So apps that use navigation and tab bars to transition between views are now much easier to manage with a visual representation of how the app will flow. Navigation usually login, once it is successful sign up, whether it goes to the home page or the main page, how you are defining. Suppose in case of the bad credentials, whether it has to be stay back to the same view or it has to be redirect to the some other page which the user is not going to allow to enter the credential, re-entering the credentials to it. So how you are designing such kind of flows, navigations, transitions between one view to another view can be designed in this design page, right? So if it is visually, it is if you are able to represent it visually, it is it is more easy to understand. So as the proverb says that one picture is better than 1,000 words. In that sense, you can clearly identify the navigation between the different storyboards or the activities. So we will see the graphical representation using storyboards here. One simple example I have taken here. Observe here in the on the screen, you are able to see the diagram, pictorial representation of the storyboard and the connection between the each storyboard. See, there is a tab bar controller. It is a main, as of now, this tab bar controller is the entry point of your iOS application. If you design this one tab bar, in this application, you have three different views. So if depending on the control of the flow, depending on the conditions, whether it has to go to the first view or second view or third view. This is the graphical view representation and flow and navigation between the two view switches. All those things are defined very clearly in the storyboard, which is given in the Xcode IDE itself. Okay, with storyboards, you will have a better conceptual overview of all the views in your application and the connections between them. So you observe here, connections between these three apps are not directly connected with that, but it is indirectly connected through the tab bar controller. So depending on the navigation type, whether the control switches from first view to second view, or back to tab bar controller, or back to the third view. So it is clearly defined in this storyboard visual tool. Clear? I hope I made you little understand of the iOS project structure. Fine. Then the iOS simulator. Again, it is a testing tool. iOS simulator is a testing tool like your emulator of the Android Studio. Similar to that, it's a testing tool. So one more testing tool which we were discussed in the introduction part itself from the tool set of the SDK of the Apple Store, right? The iOS simulator is very quick to load compared to other simulations for other mobile platform. As it is, as Arthur said that it is a very quick to load compared to the other simulation. This iOS simulator is also a great tool for HTML and CSS experts to have installed as well to test mobile web pages rendered within the mobile Safari web browser. Earlierly, the web browser Safari was available with only the iOS application, but nowadays even it is available for our Windows users also. Okay, and one more thing, always you remember that there is another topic of interest was there, Web 2.0 and rich user internet applications. It's another important topic. There it uses the Adobe Flash technology. So iOS supports the Adobe Flash. Even Android Studio nowadays, because Flash is a rich GUI interface, it consumes the more processing power and rendering capabilities. So during the earlier age of this Android, it was not supported very clearly in the Android. So that's why they dropped out. But nowadays, the industry needs a more gaming needs some more gaming applications. For that applications, usually the Flash kind of GUI, the rich GUI and 3D graphics also needed. So it needs a more CPU power and consumption of even battery also, and also space also. So since the advantage in the technologies, even Flash also supported in nowadays Android applications also. So in beginning era of this comparison with the iOS and Android, so early stage of iOS, they started using the Adobe Flash kind of application. So that was the difference. But nowadays, most of the features enabling capabilities are same except the security. Today you can identify iOS as more secure than the Android because unknown third-party services cannot be installed directly onto the iOS. It is totally entirely restricted to install. Okay. This is the one simulator of simulating an iPhone and simulating an iPad. So simulating the iPhone and iPad, it is looking like your real-time device, like an Android emulator, Android virtual device, right? Here iPad is a tab. It is tab kind of a device. It won't support the calling facility, but it supports the internet services. iPad. The difference between the iPhone and iPad is both iPhone supports the calling facility with internet and all the things, all the other services. Here it is only support the internet service. It won't support the calling service. iPad, right? So, and one another nice feature of iOS simulator is ability to test various iOS versions. Even Android Studio also able to support various version. So previously, before advantage in the Android Studio, iOS was well in advance. They deployed all these features in their Xcode environment. Okay, so nowadays less in comparison. So feature wise, because most of the things what it is supported in iOS also supports in the Android Studio also. Okay, you can select the versions and you can run. It's a built-in Xcode feature of simulator. So this screenshot, it shows 5.0, but latest version is 14.1, right? But 12.1 phones are available in the market. So one screenshot I have taken from the textbook, text reference book. It shows the debugging your iOS. So I'll increase the size, screen size. 1 minute. You are able to see that. So the debugging tools within Xcode are located at the bottom of the workspace window. If you don't see the debugging tools, you can click View, Debug Area, show debug area from the Xcode menu. See, observe here, it is clear, it is shown here. If it is not visible at the bottom, go to the View, Debug Area. Again, these options are depending on the version of the Xcode. This is older version Xcode screenshot what I am showing here. So latest version, it might differ, little differs, but usually most of the components are maintained in the same menus. So debug option, show debug area, it shows the bottom area of the debug code. And try to identify the programming language which it is used to develop. I'm increasing, zoom in. Try to identify. See, pointers are used here. You just observe NS error, star error. Star representation is pointer representation. Is it or not? If a pointer representation is there, either it is C or Objective C. So latest object-oriented concepts won't much use of the pointers, right? You can able to visible this one, right? Fine. Some Objective C basics. So why I'm going to discuss this one is previously Objective C was the main motto of the iOS, but nowadays Swift language most widely used. So Objective C was created in the early 1980s by Brad Cox and Tom Love. So Objective C main language on next operating system. Next operating system is next step operating system. Usually this is object oriented language based on the C programming language. See, again, C is the main motto behind the iOS phone again. So C is a mother of all languages, as we heard about this, right? Objective-C adds small talk style messaging, and it requires develop to declare a class in an interface and then define the implementation. So in Android, we use the Java implementation. Here, Objective-C or the Swift implementation. In Android, either Java or the Kotlin implementations. Right? Nowadays, Kotlin is becoming popular because it is a reduced code of programming language compared to a Java program. Okay? Is it clear? Any questions are there? Any questions? What and all we discussed now? iOS internal project structure, Xcode IDE, human interface guidelines, iPhone SDK tools, then the storyboard, then the simulator. Okay? And little thing about the objects. Just definition I have kept as a slide for you. Right? We will go little detail about the Objective-C in the next coming session. And those who are those who are attending the class, complete the quiz. I'm reposting the link now again. Those who are completed, ignore it. Those who have to complete, just complete the quiz. By that time, those who late joined, I'll take the attendance. Any questions are there? Let me know. Otherwise, I'll stop recording the session. I think all of you are listening to me. Yes? No? Yeah. Okay. Thank you.
Sir, attendance, sir.
Ah.